What's up guys, welcome to Rotor Riot and welcome back to Learn to FPV. Today we're going to be talking about VTXs or video transmitters. So I'm going to run down the different specs and features that you should be looking for. So the first thing to look at is the size and the mounting options of the video transmitter you're looking at. So depending on which size of frame you're going to put it in, it may or may not fit. So a super tiny micro, probably not going to fit this video transmitter. So you need to make sure you're getting a small one that's going to fit with that. Once you get into a larger frame, you can pretty much go with whatever you want. So you can go with the biggest one, or a smaller one is still going to work and it'll save you some weight. Another thing is which different mounting options you have. So all of these that I have, there's not really a specific mounting portion to it. I usually just use double-sided tape and stick it down to the frame. But other video transmitters will be stack mountable, or what I mean by that is they'll have holes where you can slide it down onto standoffs or bolts or screws, and it can be a little more convenient in some situations to have that. So in particular, maybe you have a really small frame and you can just stack pretty much all your components right on top of each other. It doesn't need to be very long. Other times, even if you are going to mount your video transmitter in the back part of the frame where most frames are kind of designed for it to go, instead of using double-sided tape, you could use some standoffs or screws, bolt it down into that. It can be a little more secure that way. It can allow for a little more airflow because air can flow under it and over it, which is important because video transmitters tend to get very hot. So not crucial which way you go. It's just going to kind of depend on which frame that you want to put it on. Okay, a really big thing to look at in your video transmitter is what is the input voltage capability. Some video transmitters can only handle 5 volts. So if you were to accidentally wire it up to where it's going to get full power of the battery, plug in the battery, you'll smoke the video transmitter. I've done this a couple times because I almost always use a video transmitter that can handle the full power of what my battery is, and the way that I wire it up is so that it gets full power. But there's been a couple times when I use a video transmitter that can only handle 5 volts, and I'll just kind of forget and wire it up like I normally would, plug it in, and poof, it's gone. So it's important, again, understand the voltage range that your video transmitter can handle. And then once you've picked what you're going to use, make sure that you're wiring it to only get that much voltage and not anything more. Next up, we have the power output on the video transmitter. So this is going to be displayed in milliwatts. So usually the range is anywhere from 25 to about 800. There's maybe some a little bit higher, but that's typically the range you're going to find. So it's not always necessarily the case that you just want to run the most possible power. In some situations, like in racing for example, if you want to get a lot of guys in the air and everybody have good video, it's better to run low power. It's going to be enough to get out on the field where you're going to be flying, and it's not so much that you're starting to interfere with each other. There's also other scenarios where the environment that you're flying in is going to bounce the signal around. So by you running a really high output, it can actually make the video a little worse because it's amplifying how much the signal is bouncing. And when you get the video bouncing, basically what that's called is multipathing. That's when you're getting the signal from the drone, but then you're also getting a reflection bounce to you at the same time. And this can just cause interferences and a little glitch and pop in your video. So in some scenarios, some environments, actually lowering your power could possibly give you a little better video performance. But also in general, more power is going to be more range. The further out you're going to be able to fly, the more things that you can kind of penetrate through. So I would probably recommend get something that has the capability of 800 milliwatts, or 600 would probably get the job done too, but it is also switchable. So if you need to, you can back it down. If you're going to go to a race, you're only going to be probably allowed to use 25. So I wouldn't get something that's locked off at a high power. Make sure it's switchable, and generally probably shoot for the one that's capable of more. Next, we have the different types of connectors on the video transmitter. So you're going to have 2 of them. One is going to be for your antenna to attach to the video transmitter, and the other is going to be for your wires coming off of it to go to the flight controller or directly to your camera, depending on how you have it wired. So for your antenna, there's really 2 main types. There's UFL, or U.FL technically is what it's called, and then there's MMCX. So a UFL is what's on this one, These have been around a little longer. They're a little smaller, a little more lightweight, but the downside is they can pop off easier. So usually if you have this type of connector on your antenna or the pigtail that's going to go to your antenna, you're going to want to have it secured down somehow. So a lot of times when you first get it, it may have like a little bit of like glue over it, or some people will kind of like wrap tape around it just to make sure it doesn't pop off really easily. Because in some cases it can kind of look like it's attached, but it's actually not. And it's going to affect your video performance, and it's also going to be bad for the video transmitter if that's not connected. It really needs the antenna on it. You never want to power a video transmitter without the antenna. The antenna is kind of acting as a resistor and taking the load that the VTX is pushing out, and it's just not good not to have that. Now, with the MMCX connector, it's a lot stronger connection. They're a lot harder to get on and off. You get a nice click when they click in. The downside is they're slightly bigger, maybe slightly more weight, and the other thing is it doesn't rotate. So depending on how tight your frame is and like how everything is laid out, it can kind of take up more space, because if you can see, pretty much from the edge of the video transmitter out to here, I can't make that any smaller. Whereas like this one that has a UFL, it's under the heat shrink, so I can't really move it. But a UFL connection can rotate. So I could put this antenna pigtail coming out at any angle, and it doesn't take up any extra space. So it's minimal, but in some frames, space is tight, and this is going to make a difference whether or not it will or won't fit. And depending on how you have this mounted and which direction your antenna is, it's just something to think about. So again, UFL, not quite as good of a connection. It can pop out a little easier, but it's a little more flexible in which way your antenna can be coming out. So the other connector you're going to find on a video transmitter is for your wiring. So there's basically two types. You're either going to actually have a connector that you can just plug right in, makes it a little bit easier, or like how this one works is you actually solder your wires to it. And there's pros and cons to both. I wouldn't really say one's better or worse. Obviously with the connector, it's very easy. You just plug it in. That's all you have to do. With soldering, it's a little more work to do. You have to solder your wires to it. But the upside is with the plug, sometimes you can get in a crash and break it or rip it off, and then it can be difficult to keep using that video transmitter. Usually VTXs that have a plug will also have little pads that you could solder to, but they're usually going to be smaller, a lot more difficult to solder than one that's kind of meant out of the box to be soldered to. So just something to keep in mind. Okay, another big feature of some video transmitters is whether they do or do not have smart audio or tramp protocol. They're both kind of mean the same thing. You're probably going to see the blanket term be called smart audio. It's the more common referred to one. But essentially what both of these things are is a communication protocol between the video transmitter and your flight controller. And what it allows you to do is change the channel of the video transmitter through your OSD on your goggles. I would highly recommend this, because another thing about video transmitters that I haven't really mentioned, and I think it's kind of obvious, but it's worth talking about, is there's different channels. This is how you get more than one person to fly at once. So you need to coordinate when you're flying with other people on what channel you're going to be on. You can't be on the same channel or else your video will just interfere. You can't be on a channel right next to each other. Same thing, your video is going to interfere. So being able to switch your channel through the on-screen display has been a huge benefit in FPV. It's made it so much easier. There are other ways to change your channel, but nothing is as easy, in my opinion, as doing it through smart audio or tramp protocol. So I would highly recommend go for a video transmitter that supports that. So now if you have a video transmitter that does not support that, you will probably always have a way on board to change the channel. Typically nowadays, you're gonna have a button and a series of LEDs. So one's gonna be for the band that you're on, and the other row is gonna be for the channel. So it's usually a long press to change the band, short press to change the channel, which isn't too bad, but a lot of times if your build is tight, it's hard to get a finger in there and see the LEDs. But at least luckily we've gone away from dip switches. I don't think pretty much any current video transmitters use dip switches anymore. Those are a real pain in the butt, because you would have a series of switches that can go up or down, and there'd be a combination of up, up, down, down, or down, up, and that's how you would change your channel, which was just a pain. You needed a small little tool to flick them up and down, and you need to be able to read the manual correctly because it would just be either a black box or a white box to indicate up or down, but they weren't consistent in whether black meant switch up or black meant switch. That was a pain. So a button and LEDs, definitely a lot better, and even better than that is your smart audio or tramp protocol. So again, highly recommend being able to switch your channel through your OSD. It's by far my favorite way to do it. And there are some other ways that you can change your channel as well. So Immersion RC has their wand. It's basically just this handheld device that you can, tune it to the channel that you want your quad to be on. You wave it over this little adapter board, and that will change your channel. I think TBS has done something recently with barcodes where you can point the camera at a barcode and that will change the channel. But I haven't really used either of those personally. I just like using through the OSD using smart audio. That's my favorite way. And lastly is the different types of channels that the video transmitter is capable of broadcasting on. It's not super critical because pretty much any video transmitter is going to broadcast on some channel that any goggle will work with, but not all goggles or goggle receivers in particular can pick up every channel that a video transmitter is capable of broadcasting on, and not every video transmitter is capable of broadcasting on every channel that a video receiver is capable of. So you want to know that they're going to work together. So the different channels or frequencies that we use, it can get a little confusing. So like I said, there could be up to like 40 or more of them, but there's only so many that we ever actually use. So the basic way it works is you have bands and you have channels. So for each different band you have available, each one of those bands will have 8 channels in that band. Now, some are a little easier to work with than others, and some are kind of just completely irrelevant and we never use them. Reason being is some are nice and equally spaced and they go in order from lowest to highest. So 1's your lowest channel, 8's your highest channel. It's a little easier to work with. Some are high channel, low channel, they're kind of just all over the place, or they work down and then up. And then other ones are just like in between channels of other bands. So if you were to mix this guy's on this band and this guy's on that band, you may think that you're on totally different channels, but you're actually very close to each other. So even though it says 40, there's really, we can get about 8 people in the air at a time. Now the band that I like to use is race band. So what race band is, before we had race band, to get 8 people in the air together at the same time, we had to use multiple bands because no one band on its own had enough separation between the channels that you could actually get someone on every single channel. There would usually be some bleed over. So what race band does is it spreads each channel out a little bit more, and it's also in order from lowest to highest. So it just makes it the easiest to use. One thing you kind of have to understand is all the different frequencies. You're going to hear like I'm on 5800 or 5740 or 5658. It can be really complicated to memorize every different frequency and what band it is and what channel it is. Race band just makes it easier, especially if the whole group of people that you're flying with is on race band. So you wouldn't have to know the specific frequency that you're on. You could just say, I'm on channel 1. And if everyone else that you're flying with is on race band and nobody else is on 1, you're good. So you'd usually want to skip either 1357 or 2468. And you can easily, with any group of people, get 4 guys in the air together without any problems. So race band just makes it really easy. So to wrap it up, I would look for a video transmitter that can do at least 600 milliwatts, but be back down if you need to. It should have smart audio or tramp protocol, and you should be able to get race band on it. Now, maybe the one exception is if the goggles that you have can't pick up race band, then maybe race band's not such an important thing. But those are the things that I would look for in a video transmitter. So with that, thanks for watching, and this has been Learn to FPV.